Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to learn how to balance chemical equations by the method of half reactions. Because if you tried to balance this chemical equation with traditional means, like that was taught at the very beginning of all of these video series that I've been doing, you wouldn't be able to. So we have this thing that's called by method of half reactions. And these are the steps that we're going to follow. Okay, now a clear indication that you have to use this method is at the end, you're going to see either the word acidic or basic. And that's an indication that you're probably going to have to use this method. So this method's kind of like a specialty tool. You're not going to use it very often, but when you do need to use it, you're going to be glad that you have this kind of like tool in your toolbox of chemistry things that you're able to do. So let's go ahead and work the first problem. And what we're going to do is we're going to do these 7 steps because it's acidic. And if it was basic, okay, we would do the same 7 steps, but we would do this note at the bottom. Okay, so the first video that I'm going to do, though, is going to be an acidic solution. So we only have to follow these 7 steps. The next video is going to be in basic solution, where we're going to have to come down here and use this note. So the first step is to write 2 incomplete half reactions. So when I look at this, I notice that there's a manganese side and there's a carbon side. So I'm going to kind of put the manganese on one side and the carbon on the other. So I'm going to label this as step 1. And over here, I'm going to go ahead and put the manganese part. So it's MnO4 minus. And then on the right-hand side, it's going to be Mn2 plus. And then for step 1, I'm going to do the same thing, but for carbon. And it's C2O42 minus on the left-hand side and CO2 on the right-hand side. So all I'm doing in step 1 is getting a manganese side and a carbon side so I can have 2 incomplete half reactions. Okay. Step 2 says to balance all the elements other than oxygen and hydrogen first. Okay, so I'm going to come in here and do step 2, and I'm going to balance everything that's except oxygen and hydrogen. And if I notice, it looks like my manganese is already balanced. So there's nothing I really need to do for step 2 on the manganese side. Now, on the carbon side, okay, I do have to do some balancing because there's 2 carbons here and only 1 carbon here. So I'm going to add a coefficient of 2 on the carbon dioxide side. So wherever I underline, that's going to be what I do during the step, okay? Now, if I was doing a real problem, I'd do this very quickly, and I'd just follow all the 7 steps. But I kind of want to do good note-taking here because I'm learning this for the first time, okay? So step 2 is done. I balance all the elements other than oxygen and hydrogen by adding a coefficient of 2 to balance out my carbons on the right-hand side, okay? And now this is where it gets a little crazy, okay? Step 3 says balance all the oxygens by adding water molecules. We've never done anything crazy like that, but that is part of the method of half reactions. So I'm going to balance out the oxygens by adding water molecules. That's what I'm going to do in step 3. Now, on the left-hand side, I have 4 oxygens, so I'm going to add 4 water molecules on the right-hand side so that both sides have the same number of oxygens. So here comes the 4 water molecules, and now I have 4 oxygens on both sides of the equation, okay? I'm going to do that the same thing in step 3 down here, but look, I have 4 oxygens and 4 oxygens. I don't need to add any water molecules on the carbon side because the oxygens are already balanced when I added that 2 in that last step. So no water molecules are needed on the right-hand side. Step 4 says balance out the hydrogens by adding protons. I want to remind you that protons are hydrogens with a positive 1 charge. So the reason we have to do that is because we just added all these water molecules. And when we added water molecules, we got hydrogens in there. And now we need to balance out those hydrogens by adding protons. That's what it tells us to do in step 4. So I got 8 hydrogens on the right-hand side, so I'm going to have to add 8 protons on the left-hand side to balance out the hydrogens. So let's go ahead and finish everything here. And over here for step 4, I'm going to have to add protons to balance out the hydrogens. But remember, I didn't add any water molecules here. And since I didn't add any water molecules here, there's no hydrogens to balance. So it's just the same thing. So when we look at this step, the last 2 steps, there's nothing underlined because I didn't have to do anything for step 3 or step 4 in the carbon side. Okay? And then it comes to step 5, and I like to circle number 5 here, okay, because I think this is kind of like the hardest step for students to do. Okay, so what we're going to do is we're going to end up adding up the charge on both sides of the equation. Okay, so let's go ahead and do that now because it tells us to balance the charge by adding electrons. So I'm going to balance out the charge. Let's figure out what the charge is. Okay. So for this first problem, we got 8 positive ones and 1 negative one for a total of positive 7. This side has a positive 7 as far as the charge is concerned. Over here, we got 1 positive 2, and we have 4 neutral things. So if we have 1 positive 2, then this side is going to be a positive 2 when it comes to charge. Okay. So if we have that situation where we have a positive 7 on one side and a positive 2 on the other side, well, to balance out the charge, we're going to need 5 electrons. So I'm going to add 5 electrons to the left-hand side because 5 negative things plus a plus 7 would equal a plus 2. Okay, so I'm going to underline the 5 electrons because that is what I changed in step 5. Everything else is the same. I'm going to do the same thing on the right-hand side. Okay, on the right-hand side, I got one thing that's a negative 2, so I got a negative 2 charge on the left-hand side, and I got 2 things that are neutral, so really just no charge on the right-hand side. So in step 5, if I'm adding any electrons, it's going to be on the right-hand side. It's going to be 2 of them because 2 electrons with a 0 charge would be equal to a negative 2 charge. C2O4 2 minus. So the things that I did here in this problem is adding electrons, okay, to the appropriate side to balance out the charge, okay? Well, step 6 says that we're going to have to multiply each half reaction so the total number of electrons will equal each other. And we need them to be equal to each other because they're eventually going to cancel out because we can't have one thing losing 2 electrons and another thing gaining 5 electrons. The electrons will have to be the same. So if I have a situation where I have 5 and 2 electrons, I'm going to have to multiply this side by 2 during step 6, and that will give me 10 electrons. And therefore, on this side, I'm going to have to multiply by 5, because if I multiply this by 5, I will get 10 electrons. We want these electrons to match. So I'm going to multiply this entire thing by 2, and I'm going to multiply this entire thing by 5. So 2 times 5 is 10 electrons. 2 times 8 is 16 protons. 2MnO4 minus 2Mn2 plus, and 2 times 4 is 8 waters. Okay, so I just multiplied each of these things by 2, so I'm going to go ahead and underline those coefficients. On the right-hand side, I have to multiply by 5. So this is going to be 5 C2O4 2 minus. 5 times 2 is going to be 10 CO2s. 5 times 2 is going to be 10 electrons. So do the multiplication, that's what I had to do. And then we get to our last step where we have to add the two half reactions together. So when you add the reactions together, you take these reactants and you put them together. So that's going to look something like this. 10 electrons, 16 protons, 2 MnO4 minus, and 5 C2O4 2 minus. Okay. And then the right-hand side is going to be all the products. Okay, so 2 Mn2 plus and 8 waters. And then 10 CO2 and 10 electrons. Okay. And what we do now is we look for like items. Okay. Now the first like item that you should cancel out are going to be the electrons, because in the previous step we were trying to get those to match. So the electrons are canceled out, and that should happen every single time when you do these problems. Okay. Now the other things that you tend to cancel out are things like protons and waters. But remember, I only added the waters and the protons on this left-hand side. I never did it over here on the carbon side, so there's really nothing that I have to cancel out. Okay, if I did add waters and protons on this side, there'd be more things to cancel out. But this is your answer. This is what you get when you balance the chemical reaction according to the method of half reactions. I got 2 manganese on both sides. If I look at the carbons, I got 10 carbons on both sides. I got 16 hydrogens on both sides. And when I add up the oxygens, we got 8 and 20 here, so that's 28. I got 8 and 20. I got 28 on both sides. Everything is balanced. And you would not have been able to get this answer by traditional means of balancing chemical reactions. So this is the method of half reactions for balancing reactions. And the thing that tells you have to do this process once again is when you see acidic or basic here. And this problem was acidic, so we didn't have to do this last step for basic solutions. Our next video is going to be an example of a basic solution. So that's where you get to see this one additional step. If you found this content helpful, please give it a like and subscribe, and I look forward to seeing you in the next video.